I can get other old, if you guys want other old exams too, I can go get some other old ones too. It's up to you. So what if using the numbers 0, 1, 4, 5, 7, and 9, how many even numbers can be formed if it's a 3-digit number? You know what, sorry, I'm going to throw one more number on here. I'm going to throw a 6 as well. 0, 1, 4, 5, 7, 9, 6. Okay, this question involves what? What procedure, what strategy? Yeah, so slots, like that. Okay, 3-digit. Is there a restriction? 2 of them, right? First restriction, it can't be 0, right? Second restriction must be even, so that means my last digit has to be a 0, a 4, or a 6. So 0 causes the problem, right? Because there's a conflict. So this can't be 0, so that means this could be, well, I guess it could be 1, 4, 5, 7, 9, or 6. But actually, 0 is a problem. 4 and 6 are problems too, right? So if I say not 0, I have 1, 2, 3, 4, 5, 6, but then my even numbers are here. So I'm going to use cases. So if I have, maybe I'll even do 3 cases just to make sure I don't make any errors. I could do this with less than 3 cases, but you know, kind of how I've told you. I have this set of numbers here, this set of numbers here, so I'm going to do cases ending in 0, 4, or 6. Like I say, there's fast ways to do things, slow ways, or sometimes good ways, right? If the 0 goes here, I have all these numbers available, of course. So I have 6 numbers here and 5 here. And no repetition. If it doesn't say anything, it's usually no repetition, but the question should say. I should have said no repetition. Okay, 6, 5. If my 4 goes here, 4 is gone. Or sorry, 4 is gone, right? So 4 is here, it's sitting here. So that means I have a 1, 5, 7, 9, or 6, right? 5 numbers to pick from, and then 4. If 6 is used here, it's not available for the first position. So again, I have a choice of 5. And I have, 1, 2, 3, 4, 5, 6, 7. Oh, I made an error, right? I have 7 digits in total. I have to scratch this out. 2 of my numbers are used, so I have 5 left for the middle. Sorry about that. Screwed up. So 30, 25, 25. 30 plus 45, 75 digits. I'm using the digits 0, 1, 4, 5, 7, 9, and 6. So I have 1, 2, 3, 7 digits in total. So when 2 of them get placed, I have 5 left over, right? Oh, sorry. Yes, thanks, Eileen. Oh, it's a good thing I'm not writing tomorrow, right? Thank you. 80. 50 and 30 is 80. Okay. No? Okay. What no? Okay, so let's do using, I'm going to do this again. 0, 1, 4, 5, 6, 7, and 9. Okay, case 1. And because I know this, okay, case 1 can't be 0, right, Rahel? So it could be 1, 4, 5, 6, 7, or 9. Sorry. And then this one can be 0, 4, or 6. Agreed? And this one can be any number, any digit left. Agreed? So I'm going to separate it to 3 cases because I have more numbers here than here. So I'm going to separate it by 0, 4, 6. Okay? So case 2, here, I'll just say cases. Case 1, case 2, case 3. Case 1 is ending in 0, okay? Case 2 is ending in 4. Case 3 ends in 6. Then I have all my cases taken care of. Agreed? Okay, so if 0 goes here, it's gone. So that means I still have all of these guys because that doesn't affect anything. So I can choose from 1, 4, 5, 6, 7, and 9. Agreed? 1, 2, 3, 4, 5, 6. I have a choice of 6. Okay? Now one of these numbers went, so 0 is gone, and one of these guys is gone. That leaves me with 1, 2, 3, 4, 5 digits. Okay, let's do this one. 4 is going to go in my last position, so it's gone. Let's do it this way maybe. Okay, so 4 is gone. How many choices do I have for the first position? I can't pick 0, so 1, 2, 3, 4, 5. Okay, so one of these guys is gone. I'll just put my finger over one of them. 1, 2, 3, 4, 5 are left. Okay, so same thing here. If 6 is used up, it's gone. That leaves me here with, so 6 is gone. I can't use 0. 1, 2, 3, 4, 5. One of them, like 2 of these digits are gone. 1, 2, 3, 4, 5. Okay, high. Sorry, should have told you guys. I knew we were going to be bumped, I just didn't know what room. Yeah? Yeah, you could do it. You're still, you got 80, right? You still got 80? Yeah, you can do it other ways. Yeah. There's always more than one way to do a question, right? I break this one down like so it's just maybe easier to see. I don't know. Okay, anything? What else? Any other questions from you guys? No? Should I pick up questions that you guys? Should I pick up questions that I think you guys should do, or? Okay. I'm going to pick out from the pink book, I'm going to pick out a couple questions that you guys should know for sure. I mean, I did some yesterday, and I remembered I forgot to post them, so I'll have to post them. Okay, let's do question 1. Avery has 4 adventure books, 5 mystery, and 1 comic. Determine the number of ways he can arrange all the books if each type of book must be grouped together. It's a grouping question. And we're going to do a couple of graphing too. See? Yeah, I was going to say is that better? I don't want to turn them all off because I think those are too dark. This one? I'll try and make it bigger. Adam, you could move up by Eileen. What? No, I said he could move up. What question, Eileen? Oh, you're stretching? That's good. Okay. What do I want to do here? I'm going to move this up. Okay, it's grouping, right? So, number of groups. How many groups do we have? 3 groups. Adventure, mystery, comic. 3 groups. I can permute the groups, then I can permute books within the groups, right? And then you're going to find the answer, whatever that is, right? I have my calculator here somewhere. So 17280. Right? Okay. What else? We haven't really done much trig together, but you're going to get. I did some graphing questions yesterday. I'll post everything tonight because I forgot to be honest. But so we did this graphing question, right? I said you're for sure going to see something. They're going to give you a picture, and they're just going to call it f of x, and they're going to get you to do the square root or the absolute value or the reciprocal, right? So what I did here, I think I did the reciprocal function, yesterday. So for sure look for one of those. That should be easy. Here, that was solving, right? Remember, you're just solving for x, the x value. I think this one, I don't know, were there any questions that jumped out at you? I think everything seems to be pretty, I don't know, pretty basic here. Let's take a look at booklet 2. Again, in the pink booklet. Remember, you have to do your unit circle. You have to know those values. Okay. How about this one? Given that cosecant is negative 4 over root 7 and cos is positive, determine the exact value of tan. Okay, so what quadrant are we looking in, by the way? It gives you enough info. Cosecant is negative and cos is greater than 0. So what quadrant does that tell us we're in? Cosecant negative, cos is positive. This quadrant, right? Yeah. Determine the exact value of tan. So I know that tan is negative. So I have to remember that. All right, so how am I going to figure this out? This is a very easy question, and you did this a lot. What do you need for tan? What does tan equal? Sine over cos, right? Y over x, sine over cos, or y over x, I guess. So what did they give me here? They gave me cosecant. If they gave me cosecant, I can easily turn that into sine, right? And sine is y over r. So what do I need to do here? I need y over x. I have y. I need find x. How am I going to find x? X squared plus y squared is r squared, right? So x squared plus root 7 squared equals r squared, right? Yeah, so x squared plus 7 equals 16. X squared equals 9. X equals 3. Okay, perfect. So that means that tan theta equals y over 3, and it's a negative because it's in quadrant 4. So that was a very, I think, really straightforward question, and it's worth 2 marks, right? 24? Okay, identify the exact value of 2 cos squared 15 degrees minus 1. Okay, I don't have my calculator, right, Eileen? And I don't know what cos 15 degrees is, but I do have the next best thing to a calculator, which is the formula sheet, right? So what does 2 cos squared 15 degrees minus 1, does that ring any bells? That's the same as cos 2 theta, right? So in this case it would be cos 2 15 degrees. So it would be cos of 30 degrees. Okay, what's cos of 30 degrees? Root 3 on 2, isn't it? What about this one? The zeros of the function f of x are negative 2 and 3. So what's another word for zeros? What are those? X-intercepts. So whatever this function is, I don't know what it is. They just gave me generic f of x. I know that the x-intercepts are negative 2 and 3. Identify the zeros of the function 2f x minus 4. So what changes do you see here? What does the 2 affect? The vertical. So that doesn't change the x-intercepts. The minus 4 changes the x-intercepts, right? What does it do? Shifts them 4 to the right. So negative 2 plus 4, that would shift me to what? 2? And 3 becomes 7. So I'm looking for the new zeros of 2 and 7. Okay. I will let you work on your own, because I think it's helpful that you do work through this stuff on your own, because you know better what you want to work through. But I just want to just identify a couple questions for sure that you're going to see something similar that I think you will. Like, what about this one? Sketch the graph of 6 over x plus 2, x minus 3, state the y-intercept. So what would you do with this graph? We haven't done one of these in a while. Vertical asymptote. So what's the vertical, what are the vertical asymptotes? X equals 3, right? What about horizontal asymptote? Is there a horizontal asymptote? Y equals 0, right? Because x is on the bottom, nothing on the top. Okay, well that gives me some place to start with, right? So I'm going to do a negative 2, and I'm going to do a positive 3, and then I'm just going to sketch this in. So I have 3 sections I have to graph. 1, 2, 3. The other thing that we always did, or I don't know if you remember or not, but it doesn't look like there's any x-intercepts. I'll just double check that. So if I put a 0 in here for y, and then I go 6 over x plus 2, x minus 3, I cross multiply, I get 0 equals 6. So that's telling me there's no x-intercepts. Okay. And the y-intercept, though, if I put zeros in for x, I get y equals 6 over 2 times negative 3, negative 6, so negative 1. Okay, and that's what they wanted down here. They want me to tell my y-intercept, so I'm just going to record that here. If they give you a space, put the value in the space they give you. So I have a y-intercept here. I'm pretty sure I know what's going to happen here. I bet it's going to be one of these guys, right? So I need to know what happens here, here, and here. My asymptotes guide me, so what am I going to do now? Test point. So 1, 2, let's do negative 3. X equals negative 3. Just substitute a negative 3 in. Y equals 6 over negative 1 times negative 6. So that's positive 6. So y is 1. So at 1, 2, 3, y is 1. I'm pretty confident with my asymptotes that it's going to look like this. And then here, I think I'm going to get the same thing, right? Let's take 1, 2, 3, 4. X is 4. Y is 6 over 6 times 1. Sure enough, it's the same value. Okay. Should we do another test point here? Let's just check X is 1 right here. So Y equals 6 over 3 times negative 2. So that's negative 1, right? That's weird. It shouldn't be negative 1, right? It can't be another negative 1. It is? It goes like this? Ooh. It's weird. I'll have to take a look at that. Y-intercept 0, 2 times negative 6, negative 1. But if I put a 1 in, sorry, 6 over 3, 1 minus 3 is negative 2. Something's wrong here. I can't figure it out. It shouldn't be a straight line there, but okay, so sketch the graph. Let me do this quick. 6 over 2 times negative 3. 6 over 3 times, oh, hang on. It's 3 times -2. Yeah, I don't know why. That's weird. It usually doesn't happen that way. Okay, so here's your picture, and there's your y-intercept. Don't forget to... I just want to talk. You're going to get probably something like this, right? It takes a lot of work. What else? I'll do, I wasn't, I mean, I did quite a few yesterday. What about this one? State a possible equation of f of x. What kind of graph is it? It's a radical graph, right? So I know it kind of starts like that. So what else do you notice about this radical? The normal radical looks like this, right? 1, 2, 3, 4. Yeah. So it's reflected in the y-axis, so all the x's are their negative, right? What else do you notice? The first, it's supposed to be up 1 over 1, and this guy looks like it's up 2 over 1. So it's a stretch, right? Vertical stretch of 2. I think that's, what else has been happened to it? So it flipped, and then vertical stretch, and then something else. If it just flipped and did the vertical stretch, it would look like that. Shifted to the right one, so that looks like this, right? So 2 root minus x minus 1. There are other possibilities, right? But that's probably the most generic possibility. What else? Okay, I'm going to make you do 2 more things, and then I'm going to let you work on your own for a bit, unless you have questions for me. So I'm in the Lilac book, book 2, because we haven't done much graphing, and I've got, first of all, let's do this one, question 46. It's only 1 mark. What's the equation of the horizontal asymptote of 3x over x minus 1? So it's horizontal asymptote. So I'd have to say y equals 3. The powers of x are the same, so it's just the coefficients on the same powers of x. And then the last one I'll make you do is this one, 47. So it says sketch the graph, and it's 4 marks. Sketch this graph. So I'm going to give you a couple minutes. The highest mark value in pre-cal is a 4-mark question, right? So this is one of the larger questions that you'll see. You did that one already? Yeah. Okay, you want to talk about it? What do you have to, what type of function is this? Is it a radical? Rational. So rationals have lots of parts to them, right? They have lots of parts, but that actually makes them easy to graph, I think. So the parts we have to be worried about are, I think, asymptotes, right? And then x-intercepts, y-intercepts. Sometimes that's enough for us to graph, but if not, then we substitute maybe a test point in, right? Okay, what are the vertical asymptotes? How did you figure that out? Yeah, you have to factor first. This wasn't in factored form, right? But fortunately, they gave us a nice one to factor. So we get what? Vertical asymptote of x equal -3 and +2? Oh, right. Someone's awake, right? X plus 3, x minus 2. Okay, where's the whole? Whole at x equals 2. Okay, I need to find the y coordinate too. So these guys are going to disappear, right? So when x is 2, y will equal 5/5, 1. So the whole's at x is 2, y is 1. I'm going to put that in right away so I don't forget about it. Okay. All right, I have a vertical asymptote at -3, 1, 2, 3. X equals -3, just to keep myself. All right, horizontal asymptote. What do I have here? I have more x's on the bottom, so y is 0. And sketch in your asymptotes, right? They're lines, so put arrows on the end, because they give you your kind of your lines to color in, right? Or stay within. X-intercept. Let's see if I put. Remember, if you have a whole, you're going to use your simplified function. Your simplified version, your simplified function is y equals 5/x plus 3. That's your simplified version. So for my x-intercept, I put a 0 in here, right? I solve and none, right? Which kind of makes sense, right? Because I have this, my asymptote is the x-axis. Okay, what's the y-intercept? Y equals 5/3, so 5/3. That's 1 2/3, so it's 1 and kind of about here. That's my y-intercept. Okay, I think I clearly see what's happening over here, right? I have my vertical asymptotes telling me the regions I have to worry about graphing. The left hand, the right hand, so I'm pretty sure this happens like this. And I do need a test point, don't I? Over on this side. I know it's a function, but I don't know if it's going to be up here or here, so I got to do a test point. 1, 2, 3, 4. I'll test point x is 4. So x is 4, y is, you're always using your simplified 5/7. Okay. Oh, sorry, thank you. -4 plus 1, that's -1. -5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. Would you do another test point, or are you okay with this? It's good? It's up to you. Would you do another test point, Neville? No? Just kind of do this? Like that? Sorry? Oh, I see. Okay. Yeah. Okay, so that's what we're looking for, right? Do you have the right asymptotes? Did you find any intercepts? Sometimes you don't get an x-intercept, right? Remember, you also sometimes get those ones given to you in this form. Right? We did a few of those. Do you remember those ones? The vertical asymptote's the same. You could actually graph this one if you wanted to, and then shift it down 3, right? That just means the horizontal asymptote is y equals -3, right? So you could do those, figure out your x and y intercepts, test points, same thing, okay? How do you figure out the inverse, the algebraic inverse? Call that y, switch x and y, then if it is inverse at the very end, switch your y back to f minus 1, right? Your answer will be in that form. And graphically, just pick a couple of points, switch the x and y values, and then plot those. Okay, anything else that's just burning up at you that you just, a question that you wanted to do, or? Carl, any questions that you really bugging you? Ibby, Adam, Neville, Eileen? Okay, well, I'll let you guys work and then call me over for independently.